Right now, inside your head, a physical tremor is moving at 300 miles an hour, bending and stretching your brain tissue. For over a century, doctors told us the nervous system worked like copper telephone cables carrying silent sparks of electricity. But that was wrong. When scientists pointed high-speed lasers at living nerve fibers, they saw something remarkable. Every time a signal passes through, those fibers swell, expand, and vibrate just like microscopic speaker cones. Think about it for a second. If nerve impulses were just electrical currents, the friction inside your tiny cell pathways would generate enough heat to literally cook your brain from the inside out. But your head stays cool. And that is because what travels down your nerves isn't a voltage drop at all. It's an acoustic shockwave. When you bump your knee against a sharp table corner, you don't fire a silent volt of current to your brain. You detonate a microscopic sonic ripple through a fluid-filled tube. Back in the late 20th century, biophysicists discovered that nerve membranes undergo a rapid shift during an impulse. In a thousandth of a second, they flash from a warm liquid into a rigid, frozen gel, and then right back again. It is sound made physical in living flesh. If you are drawn to the hidden mechanics operating quietly beneath your conscious mind, subscribe to the Minecraft right now. There are far stranger secrets buried within human biology that we are just beginning to unlock, and what we are about to reveal about the nature of pain will fundamentally alter how you view your own existence. Think about what happens inside a nerve fiber at the moment of impact. Picture a single wave rolling across the open ocean, holding its shape for thousands of miles without fading or losing energy to the water around it. Physicists call this kind of self-sustaining pulse a soliton. As an acoustic wave hits a section of nerve, the fatty outer membrane physically bulges outward by a few nanometers. Forget the idea of an invisible spark. It's a localized earthquake rolling through a living tunnel. This physical reality solves one of biology's most frustrating old paradoxes, the heat problem. Pure electricity moving through a salty solution leaves a persistent trail of waste heat behind it. But when a nerve fires, it releases a microscopic pulse of heat, only to instantly suck that exact same heat back in a fraction of a millisecond later. An electric wire can't do that. That perfect, reversible cycle is the unmistakable footprint of a sound wave compressing and expanding a fluid as it passes through. Look at the cell membrane under a high-resolution microscope. Its walls are built from two thin, flexible layers of fat molecules. Instead of acting like passive insulation wrapped around a wire, those fats behave like tightly stretched drumheads. The nerve impulse physically bends, buckles, and snaps those membranes under intense acoustic pressure. Have you ever wondered why pressing an ice pack against a sprained ankle numbs your skin long before the cold ever chills your blood? It comes down to acoustics. Lowering the temperature hardens those delicate fatty membranes, locking them into a rigid state. If the cellular wall can't flex and bulge, the sound wave stalls dead in its tracks. The electrical signal doesn't short-circuit, the instrument simply loses its ability to vibrate, and pain loses its voice. This same sound wave model resolves a legendary medical mystery, general anesthesia. For over 150 years, surgeons administered ether and gas without truly understanding how those molecules erased human consciousness. The old electrical theory offered only messy, incomplete guesses. But through the lens of acoustic physics, the truth is surprisingly simple. Anesthetic molecules dissolve straight into the lipid walls of your brain's neurons, shifting their melting point. They soften the membranes so much that sound waves can no longer move across the fluid layer. Under anesthesia, your brain isn't switched off like an unplugged machine. Your nerves are simply muted, physically unable to carry the acoustic music of your senses. Every sensation you've ever known is a physical wave echoing against the walls of your flesh. Your body isn't a machine wired with copper, but a living symphony hall built of fluid and fat. You don't merely think in electrical sparks, you resonate in sound. If this changed how you see your own body, subscribe. There is far more hidden inside you that we have not explored yet. A like and a comment genuinely help this channel reach more curious minds, and that support is what makes it possible to keep producing these documentaries. Tell us in the comments what we should explore next.